Hello and welcome back. One key aspect in working with data is to ensure that the data are of superb quality. So what do we mean by this? And why do we care about data quality at all? We assume that the data stored in our research data management system describe our experiments, our simulation and so on. And we also assume that the data are correct. And indeed, if you want to make use of this data for the later analysis or machine learning and so on, that we make the assumption that the data can be sort of our foundation to learn from or to build our simulation from or to ground the analysis in. So we have different things that we need to talk about. The data values, the data types, which data are present, how they are related, and also which correlations we have between variables if we want to exploit them, for example, in machine learning. Let's take a very simple example to make this a bit more clear. Let's look at the top table. We have structured data, we have a number of variables, and we also have a true value, a label to it. So for example, we may have the values shown here on the top. But typically we'll have a lot of data quality issues as we process the data. That can include missing values or wrong labels, or we can have wrong values in our variables. We can maybe have outliers and need to think about if these outliers are data quality issue or just very rare events. We also have, in typical applications, data stored in different formats. So, for example, the true false in variable 3 may be indicated as a boolean or as a true as a string or 1 as a number. So all of those represent the same information, but for a computer they look very different. It often happens that sort of variables get reused with different meanings, and maybe that was convenient as a quick hack, but if others are not aware, that can lead to potential issues as well. So there are a lot of things that we need to think about to future-proof our data and to make sure that we can use them for analysis. We already mentioned outliers, so here we have a specific challenge. So are those outliers real in the sense that they're correct values but just very rare? Then we need to keep them. Or are they a data quality issue, like we have a wrong entry, a wrong decimal point and so on? Then we need to identify this and correct them. The key question is, how do we make sure that we treat them in the right way? Let's look at this distribution and see here. We have, for example, this blue distribution, and most values are in the central region indicated there towards the left. But we also have outliers indicated by the number 25. So very rarely we will get such an event, but then we need to decide if this is a real but rare event or if this is a data quality issue. And we can only make this distinction if we know enough about the data that we acquire. User input typically is the greatest source for any confusion. So as a rule of thumb, we want to avoid users entering systems. So if they enter a numerical value, then we may have a different range, or the comma versus dot separator different countries. We have a convention for missing values and so on. In text entry is even worse. We have lots of spelling mistakes or different abbreviations. Everyone has their own favorite convention to write something and so on. So it's almost impossible to retrieve meaningful information without extensive pre-processing. If you want to challenge yourself, try to find all ways to enter street into a text field and see if you can recover street with all the mistakes that can be made. So you can already see from such a trivial exercise that it's very difficult to represent all the information the user has entered in a research data management system. So how do we mitigate data quality issues? First of all, we need to accept that there will always be some data quality issues, and it's also a never-ending story. Prevention is here as well easier than cleaning up afterwards. So how can we make our lives easier? We can design a suitable metadata schema, for example. That means we want to be clear which variables we want to capture and also nail down the type of the variable. For example, if it's a text, or if it's a number, an integer, a float, a boolean, and so on. And the easiest way to go on is to implement such a schema in a suitable research data management system and enforce the data types and limit the amount of information that users, for example, can enter into a text field. Of course, we may need to amend our schema, and that's called schema evolution, to migrate from one schema to the next. We also can favor automatic data capture over user interaction. Anything that we can automate has less source of errors. If we have user interaction, a general rule of thumb is to avoid text entries where possible. Anything that goes into strings, varchar, and so on should be avoided, and we should limit it to names or additional comments. Of course, we cannot always do this, but if you have the possibility to not use text input but to force users to enter, for example, numbers or drop down menu and so on, it will be a little bit more effort up front, but lots of effort saved later on. For example, controlled vocabulary can be used in drop down menus, so users don't have a free choice, but they can only use predefined choices. Why is this a good idea? If users only have a limited and predefined choice, like in a drop-down list, first of all, it's more convenient for the users to have the explicit description than numerical representations, but it also means users cannot make mistakes. Of course, they can click the wrong item in the list, but they cannot make spelling mistakes, or they can't use their favorite abbreviation or variants and so on. Ideally, users cannot add new categories that are similar to existing ones, so of course we will need new categories or new items in the drop-down menu, but it should be done by an admin to sort of try to generalize. If you have too many categories as well, then it gets more difficult because they are probably too closely connected to each other. So try to come up with the choices that are suitable but general. So research data management is about making data searchable and accessible, and that also includes making sure that the data is of high quality. A detailed metadata schema, including data types, can help us pin down what can be entered where, and also prevents a lot of data quality issues. You can think about it like users are like an ideal gas. It's maybe a silly quote, but each new user will find very, shall we say, creative new ways of entering data in unexpected ways. If you create a system and give it to the users, you must be prepared so that the users have different ideas about how to use the system. So in order to ensure data quality right from the start, favor automatic data entry over manual entry and avoid text fields wherever possible. Use controlled vocabulary wherever possible instead of text entries, so that you can have less choices that are useful for the users to make mistakes in. Take a little exercise. Now devise your own metadata schema. Include the data and the data types, and then create suitable controlled vocabulary for application. And then go over it again, replace all the strings with other data types and controlled vocabulary as much as you can.